So on Friday, so this is 7-4. We left off here on this problem. So let me kind of talk through what we've done so far. Okay, so to find the focus in Directrix, you need it in focus in Directrix form. So that means you need either the x squared or the y squared by itself. So since it's y squared, I want that part by itself. It's going to look like the shifted form here, because there are other terms, like there's this other y term, and you have this extra 3 here. So we are going to have parentheses. It's going to be shifted. So I need to complete the square. I only needed to complete the square on y because that's the square term. So first thing I did was I moved the 12x and the 3 over to the right. Okay, so I could complete the square on y. So I went through and we did that, completing the square. So we got down here after completing the square. I had to factor out this negative 12 here because the x coefficient needed to be 1 as well, so I could tell where my vertex was. And then I had to divide by 3 to get it in my shifted form. Okay, so here is focus Directrix form. It's not at 0, 0, and that's why we have parentheses there. You see parentheses, so you know your vertex is not at 0, 0. It is HK. So your vertex is the opposite, your x-coordinate is the opposite of what's with x, so positive 2. And the y-coordinate is the opposite of what's with y, so 3. So we plotted that here, the vertex. Okay, since it's y squared, I knew it was horizontal. Then I wanted to find p so I could find my focus in Directrix. So I knew that negative 4, so this negative 4 is equal to 4p, which means p is negative 1. So since it's horizontal and p is negative, I know that it's going to open left. All right, I go ahead and I do my focus in Directrix now. So p is the distance from your vertex. Negative 1 means you're going to go left 1, and that is your focus. Then you go opposite of p for your directrix, so right 1. So then that means that my focus is at 1, 3, and my directrix is the vertical line x equals 3. Okay? So that is where we left off. Okay, this question also asks us to find, up here, it says find the focal chord. So that's what I need to do now. I am going to, just so we have an idea of what it's supposed to look like, I'm going to sketch in this parabola, but I will erase it and make it more accurate. So don't draw yours in yet. But I know it opens left, and here's my vertex, so it's going to look something like this. Okay? And then my focal chord is the line that goes through your focus and has endpoints on the parabola. So that right there is the focal chord. So I need to find the endpoints so I can draw the focal chord, and then that also will give me a more accurate parabola because I'll have endpoints on it. Okay, so find the endpoints is what I want to do. So the endpoints of this focal chord, that will be right like here and here. I need to find what those points actually are. So to do that, I can plug something in. What do I know that my x-coordinate is? Since it has to go through the focus, what do I know that my x-coordinate is at these two places? 1. So that's what I'm going to do, is I'm just going to plug in 1 for x. You can go to your shifted form after you've completed the square or to the original. So let's just go back to the original, and I'm going to plug 1 in for x.
Wait, how do you know it's going to go to that part? Is it through the focus?
Yes. Yes. So x is 1 because it has to go through the focus. So I'm going to plug that in. So 3y squared minus 18y plus 12x, so plus 12 times 1 plus 3 equals 0. So there's 2 endpoints, so it's going to make sense that I'm going to get 2 answers for y. So then this is 3y squared minus 18y plus 12 plus 3. 3y squared minus 18y plus 15 equals 0. So it's a quadratic, so we'll get 2 answers. We can factor it. We can make it easier to factor by first taking out a 3. So factor out a 3. Since the right side is equal to 0, if I divide by 3, then that 3 just cancels. Then it's not too hard to factor. So add to be positive 5, or multiply to be positive 5, add to be negative 6. Okay, negative 5 and negative 1. So that means that y is 5 and y is 1. So those points are 1, 5, because x is 1, and 1, 1. So you'd want to plot those points before drawing in your parabola, because that will help you drawing more accurate parabola. So let me take off the one that I already have. So 1, 1, 1, 5. And then use those to draw in your parabola. Okay, on your test, you won't have to identify the focal chord. However, okay, to draw an accurate parabola, I want you to find another point besides your vertex. The focus you'll need to find, but that's not on the parabola. Find just another point. You can do that by plugging in any number for x or y. Okay, just pick a number, plug in for x or y, and find another point on the parabola. Now, if you're going to plug in a number for x, on this one specifically, you're not going to plug in an x that's greater than 2, because that would be undefined. There's not a point over there. So, like, think about it. Put in a point that makes sense. If you know it opens left and your vertex is 2, 3, then you want to pick a point less than 2, because you know it's going to be left. Okay, so pick something that makes sense. You could pick a number for y, because you know the domain for y on this one is negative infinity to positive infinity, so it wouldn't matter. Or the range for y, I'm sorry, is negative to positive, so it wouldn't matter what you pick. Yes?
You probably did this like the last time you did this problem, but can you go over how you found the focus for this one since it's a shift in vertex?
Yeah. So we found the focus because it's what's out front. What's out front here has to be equal to 4p. Okay? So that told me p was negative 1. So that's the direction I have to go from my vertex.
Okay.
So then my vertex was 2, 3, and I had to go left.
Okay.
Yes?
What if you end up with an equation that that number isn't visible?
Then you would be going a fractional amount. I mean, you would have to divide it by 4. It won't be like that on your test. I'm trying to make the numbers nice. Yeah.
So if it's vertical and like p is negative 1, you go down 1?
Correct. Yes. Yes. Okay, so you can do the focal chord because that will give you points on there, but you don't have to. Like, here I had to plug in x equals 1 because I needed a focal chord. But just for your graph on your test, you can pick, you know, whatever you want. Just make it make sense. Like if you happen to pick like x equals 10, you would just get undefined. You have to pick a new number. Okay. Okay. So this is this whole problem. So there's questions like that on your Schoology assignment where you have to complete the square first. Okay. So we want to go backwards now, and this will help with going forwards to spend a little bit more time talking about what we have here. And we want to write the equation. Okay, so I will sketch what we have, because that helps me know how my parabola is opening, like which direction. So my focus is at 0, -3. Okay, so there's my focus. And my directrix is y equals 3. So I have to go through the y, which means that's a horizontal line. Okay, your vertex has to be halfway between your focus and directrix. So where is my vertex? 0, 0. Good. Which way will this parabola open? Down. Your focus has to be inside, and it can't cross the directrix. So your focus has to open like this. So it's vertical. I'll go ahead and write it in shifted form, but since it's just 0, 0, I'll be able to condense it. But it'll just be easier when it's not to know what the shifted form is. Because the focus has to be inside, and it can't cross the directrix. So the vertical equation, that means I need an x squared. So x minus h squared equals 4p y minus k squared. So I need h and k and p to write the equation. Well, 0, 0, I know h and k, so I need to find p. Remember, p is the distance from the vertex to the focus. So how many units is that? 3. And I went down, so p should be -3. So I went in a negative direction, so down or left, you're going to be negative. Yeah, sorry. This should not have a square. One square term, thank you. X minus h squared, there's your square term. And then this over here is not squared. Yeah, thank you. Okay. So now we can write our equation, and then we'll just simplify it. So x minus 0 squared equals 4p, so 4 times -3, y minus 0. So you want to multiply your 4 and -3. Okay. X minus 0 is just x. So that's x squared. Then what's 4 times -3? -12, and then y minus 0 is just y. All right, now we'll look at this one. Any questions about this one first? That's number 62. Okay. Again, I have to sketch what we have. So the vertex 4, 1. And the focus is 1, 1. So this is the vertex here. So, where would the directrix be? How would I find where that would be? Yeah, I need to go to the right. And you don't need the directrix for your equation, but I think that helps us see the way that it'll open now. So which way will this open? To the left. To the left. So it's horizontal. Okay, so horizontal, that means it's y squared. So y minus k squared. Remember, k always goes with y, h always goes with x, no matter which one is squared. Equals 4p x minus h. So you have h and k. But you need p. P is the distance from the vertex to the focus. So that's 1, 2, 3 units away. We went in a negative direction because we went left. So P is -3 again. Okay. So y minus 1 squared, the y coordinate goes with y, the x coordinate goes with x, equals 4p. So p is -3. So 4p is -12. And x minus 4. Okay. Okay. We are going to skip this one. It's basically the same thing as the one we just did. They just have a graph here. Okay, so let's look at this. So we have already done systems of these types of equations when we did that systems chapter. But now they have it again just because we couldn't actually graph these now if we wanted to. It'll still be easier to use like substitution or elimination. I'm going to use elimination. But let's first just talk what we have. So, all right, my coefficients are 1 and -1. So they're not the same. They're both 1, but they're opposite signs. And so what type of graph do you have when you have a negative? What would that graph look like? If you have a negative, it's, yep. I don't know if anybody else heard that. What type of graph would it be if there's a negative? So both are squared. X squared and y squared are both squared, so it's not a parabola. It's either circle, ellipse, or hyperbola. Yeah. I heard it, but I wasn't sure everybody was listening that was there. Okay. Okay, what about the second one? What type of graph is that? Circle. the coefficients of x squared and y squared are the exact same, so it's a circle. Okay, I'm going to do elimination here. So first, I'm going to rewrite this with so I can have it lined up. I'm going to put negative x squared plus y squared equals 12. So I just switched the order of my x squared and y squared. Then I'm going to add down because I can get the x squared to cancel. So y squared plus y squared is 2y squared. 20 plus 12 is 32. So divide by 2, y squared equals 16. So that means y is plus or minus 4. Okay, so we got to plug in both 4 and negative 4. You can choose either equation, top or bottom. I'm going to do the second one because they're both positives. It doesn't really matter though. So x squared plus 4 squared equals 20. So x squared plus 16 equals 20. X squared equals 4. So x is plus or minus 2. So when y is 4, x is positive 2 and negative 2. So that gives me the ordered pairs 2, 4, and negative 2, 4. Okay, now plug in negative 4. So you're doing the same thing. So x squared plus negative 4 squared equals 20. If you square negative 4, you still get positive 16. Alright, so x squared equals 4, and x is plus or minus 2 again. So now when y is negative 4, you get 2 and negative 2 again. And now these are the points 2, negative 4, and negative 2, negative 4. So you have 4 solutions, 4 points of intersection here. You don't have to graph these, but if we did, so it's going to look something like this. So both the circle and the hyperbola have centers at 0, 0. So these points, I'll go ahead and graph those first. This is just going to be a quick sketch. I'm not going to go in detail here. So 2, 4. And again, you won't have to graph these, but this is just if you're curious what it looked like. Okay. So for my hyperbola, my A and B are both going to be 12. So that's between 3 and 4. The x squared is negative, so that means it's a vertical hyperbola. So my hyperbola will look like this. And then my circle, radius of square root of 20. So it's between 4 and 5. Nope. This is just a sketch so you can see what it looks like. Okay. So then these are my points of intersections. So this is just to show you how you would get 4 points of intersection if you graphed a hyperbola in a circle. But not on the test. No, actually, it's on this part is on Schoology, but we have actually already tested on that, so it is not on your test. I will show you here in just a second what's on the test. Okay, so that is